So class, in the last lecture we discussed the use of debugging, and then we discussed the examples for how you can use the different functions to manipulate the pixels in a picture. So we did, for example, this reduce or decrease red from the picture. And finally, then we saw this function for write picture to store images on your computer. We also tried this thing where if we select the option of modulo, so in that case, when the modulo option is selected, then you will see some strange behavior, because when you add one number or one value, or you increase the value of a pixel when it is 255, if you add 1 it will become 0, which is very strange and very dangerous. Another function we saw last time, it was the set blue. For setting the blue color to 0, you don't need to read the blue color, so there is only one instruction in the for loop. So we did this last time. In today's class we will discuss another thing related to picture manipulation, which is the sunset effect. All of you know that when the sunset occurs, what is the main feature, what is the main property of the time that is in the evening around Maghrib? At that time, the sunset, when sun goes down, you feel as if the sky, it is a feeling that the sky becomes reddish. So how do we turn, for example, if this is a picture of a scene on a beach, how we can make this scene appear as if it's a sunset time, not the afternoon time? So for this purpose, first of all, we will try to increase the red color, because in the evening we feel everything that as if the sky has red color increased. So we will try to increase the red color in this picture and try to see if it helps. So let's go and work on this thing. So where is it? JS, open the JS, for example. So let me first of all, so this is it, your JS. So I will copy the code from the other example. So this code, I will take it, the one we did used last time for debugging, and I will save it as maybe C. Okay, and this time I will try to use it for making the sunset. So let's say, always when you are writing some code, especially for your project, make sure you put some comment. So comment is done by this hash sign, and you write make sunset program, and here is the image. So it is a Eiffel Tower image. I think you should go and check the folder media sources, check over there. So material, I think. So for your case, the path will be different. So, but check and see where is the beach. So beach image is beach.jpg. So I will try to use the same name over there. So here media sources, I will use beach.jpg. Okay, so let me make it more large. So this is my file. Let me use the same standard name we always used, F. Okay, this is F, and picture name is P. Okay, and what I want to do is that I want to increase the red color. to make sunset. So here remember what function I will use to select all the pixels. I will use get pixels from P, and I will use over here for pixel, I told you we will use the variable named as px. Okay, keep this line commented because you can use this line. I told you in the debugging, you keep this line. Whenever you want to debug, you will just enable this line and use it. Okay, here all these lines, remove it because I don't need two loops, only one loop is enough. So inside this for loop, what I will do is that to increase the red color, so remember, let's say r equal to get red. Whatever is the red value, increase it. And so remember, for this purpose, when I am trying to do such thing, I always want to compare the two images. So let's say that you have two images, one is called P1 and the other is called P2. So I will modify one image and the other one I will just use that as comparison. Okay, so P1, or you can say P2, I will modify. P1 will be my original image. So get red from the px, store it in r variable, and then you say set red. And here what you do is you say set red, and you take the pixel, same pixel px, and this time r will be multiplied by, for example, some bigger value 1.5. So remember, 1.5 means what? I told you last time, to understand the effect of the number, the multiplier, just consider the r value. Suppose r value is 100. So 100 multiplied by 1.5, it's 150. So you are increasing the value from 100 to 150. Clear? So here it will be 150, and here I will use, for example, P2, and then I will have also this one P1 and the next one P2, and don't need to save the image. Okay, so this is my function over here. Just read the file, make two pictures, modify one of the pictures and increase the red color by 50%, and then display both the pictures. So run this program. Here it is. So you will see the effect. This over here on the left is original image, and on the right you are seeing the image which is modified. Okay, if you are not satisfied, for example, increase more. So we increase it more, and when you try again, run it, and you will see over here, if I ask you just try to imagine with the image over here, do you feel as if it's the sunset time? Frankly, it is not. This is the original image. You can clearly feel this is the daytime in the original image. Here in this image, you don't feel as if it's the sunset time, and still you feel over here in this region the same sun brightness, the same light, and you don't feel as if it's evening. And there is one more problem that you start to see, because you are increasing the red color too much. So you are increasing, for example, multiply by 2, you double the red color, and you start to see too much red color, for example on the water over here in the shadow, and especially over here on the wall. Look carefully on the wall, you will feel as if the wall becomes a little bit pink. So this is not the correct approach. That's the problem. The scientists, they did experiment with this thing, and they found out that if you increase the red color, it will not make the sunset effect. Instead, what it will do is that it will try to make everything with red specks. So the sand, for example, it will become red sand, which is not good, and that can't be what it actually happens. The correct theory, what happens in the sunset time, the new theory, the scientists, they did some experiments with these things, and they found out that actually at the sunset time in the evening, basically red is not increasing, but the other two colors are decreasing. So original theory was this, that red is increasing and green and blue are not changing. Now the scientists, they said this is not correct. With the practice they found out this is bad approach. Now what they did is that red is constant, and they said G and B, green and blue color, both of them are decreasing. So this is what they tried, and what they did is they used less blue and green color, and that automatically makes, because green and blue are decreasing, automatically you will feel as if there is more red, but red is not changing. It's only the feeling that red is increased. Okay, so that's what happens, and that's what we will see over here. So let me close these two. This. Okay, so here it is. Now instead of working on the red color, what I will do is I will go to the other two colors, G. So read the G color, so it will be get green, and then you set the green color, and this time you should increase, not increase, should decrease it. So let me do it 0.5. So 0.5 is, you will make, if it is 100, and remember, change this variable, it's G, not R. Now just copy it, don't write everything 2 times yourself, just copy paste. Make sure they are in the same alignment, else it will become a separate box. This is B, and this is also B, and make sure this is get blue, and below also it is blue. Okay, so now what's happening, you get the pixel one by one, all the pixels from the picture, and for each pixel you get the green color, multiply it by 0.5 and set the green color. Then you get your blue color, multiply it with 0.5, means divided by 2, and then set the blue color. So we do this for all the pixels in the image, and what happens, it will make, so I am doing it a lot, too much is not good. So let me do it 0.7. So when you do like this, this time you will start feeling as if it's the evening effect, and this is the correct effect this time. You don't feel on the wall over here, you don't feel the red color has increased. You don't feel the red color increased in the sand. So this is the correct approach, and this is what is happening practically. Practically it happens the same thing. And to make sure, for example, that you have done it correctly, try to select the same pixel location at 2 places. For example, 330 and 420. So use this, and if you will see that for the 2 locations here, the color you have got is like yellowish or mustard color, and on this location you will see as if the color is brown or red, but practically the red value is same for both of the images. You see red is 243, but the other two, they have decreased a lot. 24, the green color became 157, whereas the blue color was 182 and it becomes 127. So this is what we call the sunset effect. That's what is happening over here. Make sure you pause the video and go to the JES and practice it yourself, the code. Write the code yourself. I will not write it or give it to you. You have to write it yourself. Pause the video, look at the code, type it yourself. If you don't practice, you will never learn. So this was the theory behind the sunset effect, and this is the common effect. You will see this type of effect in many different professional softwares, including Photoshop. So here it is, the same code, it's given over here. So they have created this code as a function. So remember, if you are making a function with the def keyword, then in that case you have to write the lines separately. For example, then you have to write it f, okay, and then you have to write p, for example p1 and p2, and p1 you don't modify, p2, and then you will pass the value to p2. For example, you will write over here make sunset, okay, make, and here inside make sunset you will provide the input variable p2, okay. So it will work like this. If you define a function, then you have to write these 4 lines, for example 3-4 lines, or then at the end there will be explore also to run this function. Remember, function will not run unless you you call it from somewhere. You call the function name. So when you do this, the beach image, it will become like this. It will be a dull image with less light as it is in the evening. So this is the correct sunset generation function. Clear? Take your time. Don't go next until you have practiced this. Okay? So practice it, and then we will go next. There is an image in your media sources. It's related to the church. Okay, so go to that image and use that one to so this one, church. Try to make it dark. Okay, so we want that there will be a evening effect, but evening effect should be correct one, not by increasing the red color. If you increase the red color, you will see the red tiles or the wall of the church will become red, which is not good. Okay, so do it in the correct manner, practice it on this image, and then you come back for the next topic. Clear? So after this, what comes next is the lightening and darkening function. These are 2 built-in functions. We use 2 built-in functions to create this thing. One function is called make lighter and one is called make darker. Okay, both these functions, so this is an exam question also sometimes. Make lighter, what it does, and make darker, they take the color object as input. The input is color. Remember, the previous functions mostly they worked on a pixel. Here it will take a color. Remember, one color is made up of 3. One color object has 3 values: R value, G value, and B value. Okay, so it takes the 3 color values, and so this color is made up of 3 color values, and you give this make lighter, you provide it a color, and it will return you a new color which is lighter. Now what does the word lighter mean? Lighter means that it will modify it will increase the color intensity of all the 3 values, not only one. So let me show you first. Let's create some color. So I will use this time the command area. So let me create a color. Let's say you have a color C1 equal to make color. So you remember make color command, just give it to 3 values. So I provide it 3 values: 90, 150, and 220. Okay, this is the color. You can check it. Okay, now I apply make lighter on this function. Make lighter is a built-in function. It's created by JES. You only have to use it. Okay, so when I do this, what will happen? All the 3 color values will increase. 90 value, it becomes 128. You cannot control how much it will increase. There is a percentage increase that will be done every time. It increases, I think, almost 33%, 1 by 3 percent. Okay, 1 by 3, the value 1 by 3 of the value it will increase 33%. So 90 will become 128. 150 will become 214, and 220 reaches the maximum value 255. Clear? So this is what happens with make lighter. The opposite and make lighter works on the color, takes the color as input and returns another color value. The opposite of this is make darker. Make darker will also work on the color object as input, and what it will do, yes, you can easily guess, it will do the opposite. It will decrease the color value, make it dark. So if the color is 90, 150 and 220, it will make this. So it is decreasing almost by same ratio of 33%. Okay. So if the value is 90, it will make it 62. 150 will become 105 and so on. Clear? So when you do this thing on all the pixels in the image, what will happen? So here is your function. So you get all the pixels, and one by one for all the pixels you first get the color. So you get whatever is the color of the pixel. You can call it any name. Here it is color, you can write it C1 or C or any name you can give. Same name you will use here. And then you apply the make lighter on this color C1. So when you apply make lighter, the output will be another color. Let's say this is C2. Okay, just to show you, no need to cancel these names. Just to show you, you can use any name. And then this C2, you will use it to put it back on the original pixel. Make get color and set color, they are same as get red and set red. Okay, or any other of those colors. So only what they are doing is that they will take the pixel, get the color of the pixel, and when you want to set it, you will provide the pixel and it will set the color of that pixel. All the three colors will be set at the same time. Okay, so now let's go back and we will try both these functions. The other function is same, only this command changes. Everything else is same. So here it is. So this is make sunset program. I will not disturb it. Like, let's save it. Save as. I will save another copy, and this time I will name it make lighter darker. Okay, like this, make lighter or darker, and I give it any image. Maybe I keep the same image, you can change it. This time I will use three images. Okay, one is P1 original, I don't change it, this is only for reference. P2, and then the third image, I will add three images this time. The third image will be the one which will be darker. Okay, so I will be using three images, and three images I will be having. I will first modify the lighter one. So P2 is for lighter, so I will write over here lighter. Okay, just I remove this to make more space, and this time I don't need two functions, two colors. I will only select one color, which is, for example, C. So you can give a same name C, or you can choose a different one. C1 equal to get color from this pixel. Then what to do? C2 equal to make lighter from C1, make it C2, a lighter version, and then finally you say set color and you give it C2. Is it clear? Oh, sorry, one mistake. Here you will say px comma c2. Okay, same pattern. If you remember the commands set red, set green, set blue, same. So set color, get color and set color, same thing. Get color has one input, set color has two inputs. So this will work. You don't need to write the code again and again. Just copy it, and here I will paste it, and this time write over here a comment that I want to make darker. Comments are very important for your project. Normally in the last semesters, when someone is not using comments at all, for me they lose marks. Okay, this time remember we will be using P3 image, not P2. So picture object P3. So get pixels, again you use the same variable, no problem, because remember px variable, you used it in the for loop, it is used in the for loop, outside the for loop it's finished. You can use it again, same variable name. Similarly you can use c1, c2 again, no problem. This time I will change only this thing, make darker. Okay, this is done. At the end of this whole exercise, I will have P2 image, which is lighter version of P1, and P3 image, which is the darker version of P1. And what I will do is explore all the three images. Save it, and then when you run it, it will open three images for you, and it will modify. It will take a little time, and it will open three images for you, and one will be the lighter version, one will be the darker version, and one of them is the original. So this over here on the top, the one that is opened first, that was the original image. This is the lighter version, and this one is the darker version. Okay, so unlike the previous approach where you reduced the color values yourself, in lighter and darker you cannot choose how much you reduce. Okay, if you insist that you want to decrease more color, in that case you have to call this function multiple times. Not only one time, you call it multiple times. That is the only way. Okay, so it is possible for you to, instead of writing, so let me make it large. So instead of writing the code like this, it is possible that, for example, I cut it. It is possible to write the code as functions. So let me write over here def. Instead of darker, I will, what name they have used, let me call it lighten, and you provide it a picture P. Okay, I use the same name P2 because I don't want to change it everything again. Sorry, I want to put a tab. No, why? So do it for each line separately. So make sure the two boxes are correct, one for loop box and the other is for the function. Okay, and then I will do the same thing for below. I will define def darken, and this time I define P3, but remember you can use any variable name. Again make two boxes. Okay, so you have lighter and darker versions. So one is lighten function and the other is darken function. Okay, it will run on the images and it will return darken and lighten versions. Okay, here you make the same pattern, create three images, and then you have to reduce the image color. For example, here you will say lighten and you will call P2, darken P3. Okay, remember one important thing, P2 here, it is not same as this P2. To avoid confusion, the P2 coming from the outside over there, it is just like they are different cups. This cup contains over here P2 picture, and when you pass this value, this is a new cup that's storing the picture. So you can use another variable, for example P. You can use P only. Okay, so this P has nothing to do with this P2. They are different variables, but they store the same image. Similarly, this P in the darken and P in the lighten, they are separate. They are not same. They have nothing to do. They are not common. Okay. So this is how it works. Here you use darken and lighten. You run the program again. Same result. This time you will get the same result. And again you have got three images. This is the darkest, lightest, and this is the original. Clear? Same thing. Now you have got more flexibility. When you make a code like this in terms of functions, now you have more options. For example, you can call the lighten function 2 times. It will increase the brightness of the image more. Similarly, you can increase the darkness of the image P3 more. So when you do this, 2 times means more light and more dark. Okay. Now I am calling these two images, these two functions on P2 and P3 2 times. It will take more time. Okay. Now you see it is more dark and this one is even more brighter. So much that you cannot see even this brightness. The image features you cannot easily recognize it. Too much sunlight. And this one has become more dark. Clear? So this is what is happening over here. You increased the lightness in the image. So here it is. Try to observe this code carefully and pause the video and make sure that you work on this image. You work on this code yourself. In this code, what I did is I created two functions. This is function number 1, lighten. This is function number 2, darken. Okay. And for these two functions, I have written some code over here, the Python code. And this code in the JES will initiate a call to those two functions. This code will call those functions. And to call those functions, I am calling those functions here. To call those functions, I have first to prepare the variables that will be used inside those functions. So because those two functions, they work on images, I create the images first. Okay. And when I come back from the functions, then at that time, I need to display the results. That's why I use explore. Clear? So pause the video now over here and make sure that you go back and you practice on lighter and darker functions. Okay. So I try now to keep the videos shorter. Let's do the next one also. It's easy, very, very easy. The next one is called the negative. So this is the last one we do with this video. Negative is quite easy. What it does is, if you remember, those of you who have seen the time before the digital cameras, when the digital cameras were not there, there were cameras with the plastic film. Okay, so let me check it somewhere on the internet. So here, for example, I show you. So here it is, film roll camera. Okay, at that time, what time of cameras were used with this thing? Okay, now I think you are more clear. So this was a film roll. There were many companies like Fujifilm or Kodak or I don't remember. There were many companies. What you used to do was, you had a camera. So inside the camera, you open it up and inside the camera you put this film inside the camera, and then you put it over here, and every time you take a picture, a mechanical method will roll the image. So the image will be rolled, so it will come inside over here, it will come in front of the lens, and every time you take a picture, the plastic film will move to the other side. So every part of the plastic film will contain one image. The image that was stored on this film or this plastic, it was normally in the form of this thing that we see over here. So the image that was on this plastic film, it was something like this. So it was normally called as negative. So people used to say that I have the negative of the image, I have a negative of the photo, I want to go to the shop to create the positive. Okay, so this one was below, one was called the negative, and the original, the correct photo that was developed on the, that was printed on the page or paper, that was called positive. So here we will see how the negative and positive worked. So to create the negative, negative basically means it is the opposite of the positive. So how the negative was created? For example, let's say your picture has a pixel and its red color is 10. Okay, so red color, when it is 10, it means it's a very dark red color. Okay, and negative is basically the opposite of the positive. So what is the opposite of this color 10? If the value is 10, it is dark red color. What is the opposite of dark red? It means light red, lots of value of red. And that was done using the this operation. You subtract the value from 255. So if the value was 10, you make it 255 minus 10. It becomes 245. So you do this operation for all the three colors. So if the old color value was red, the new color value will become 255 minus red. Okay, if the old color value was green, green color value was G, now it becomes 255 minus G, and similarly for blue, 255 minus B. Okay, so for each pixel what we do is that if we negate, we call it negate, change it. If we negate each color component, in creating a new color, we negate the whole picture. So you negate the each color value, you will negate the whole picture. So what you do is that you read the three color values R, G, B, and then you subtract them from 255. When you do this, you can create a new color, make color, and then set this negative color on the pixel. So you see there are three colors RGB. You create a new color with this, which is 255 minus the color value, and you make a new color and you set this color on the pixel. It will become like this, the picture. Okay, and there is another way to do this. I will show that way to you. So this was lighten and darken. Let's save this program again. This time it's E, and this time over here what I will do is that here I will create a function, call it negative. Okay, I get the pixels, and for the pixel what I do is that I get the red color, I call it R. and then I get the G, and then I get the B. Okay, three colors, and then I have got the blue. Okay, RGB. Okay, and what we do next, so in the slides, the next method that is given is that you make a new color. So in the slides it is given like this: make. So new color is, for example, C equal to make color, and then you'd say 255 minus R, sorry, R, uh, then 255 minus G, and 255 minus B. Okay, but I prefer another method that's possible. You can do another method, which is you use directly set red tx comma 255 minus R, and then you use the same command, you copy it, and you modify it little bit for other two values. So green, and it will become G, and then it will be blue. Okay, so this is it. What I am doing is that each color individually I am changing or negating it. When we subtract it from 255, what I am doing is I am making it the inverse or negate. So if the value was 10, now it becomes 245. If the value was let's say 100, now it becomes 150. Okay, so I will now try it on with only two pictures, not three. So what I do is here I will call this function negative. So I apply it on the picture P2, and when I pass it over there, P2 will be stored as P, and remove this comment. And here we have got three colors. I get three colors and I set the opposite of these three colors. So let's try this. It's ready. You run it. It will display you two images. One of them is the original and the other is negative. And the effect is more clear when you use the human face, because you remember in human face you can clearly remember the opposite negative. So here it is. You see here the color values are very dark. Okay, all the color values will be in the range of 0 to 50, and here you see it's very bright, opposite. So when you make it opposite like this, then it is the negative of the original image. So this negative is the one that was stored in the old cameras on the plastic film, and then it was converted onto the paper, printed on the paper as positive. So pause the video here and make sure you understand the code. You write it down, you show it, save it, and I will show you now the other one also, so that you don't have any doubts. Here it is. I will comment it out, and here I will put the other code. In the other approach, what they do is that they combine it in one step. Here 255 minus R, you can use any approach that you like. No problem. Even for your exams, you can use whichever you like. So I make a new color C, and this color is the inverted color or negative color. And then I will use set color on the pixel PX, and I will put the C. It will have the same effect. Now try these two lines. They are same as these three lines. Okay. I do it, run it, and it will again take its time, and it's the same result. You see 100% same thing. Here you see at the start on the top the color is very dark, it's almost black. So its negative is a color which is very light on this top. It's very light, almost like white. Okay, So pause it and make sure you run your code on using both of these methods and try to see the results. For you, for the practice, I suggest you that you take the same image as in the slides. Take this image barbara.jpg and try to produce the negative of this image. Okay. One more thing that is left that is very important to know. Let me first show you in the slides. So that's very important to remember is that if you take the negative one time, if you apply on the normal image a negative, it's like this. If you apply the negative again, it will give you the same image, 100% same image again. So you have the original image, you apply the negative, and if you apply the negative 2 times, negative is basically the same as original image. Okay. So to show you how it works, here it is. I apply over here, I create another image to show you 3 images in comparison, P1, P2 and now P3. And I create an image negative P2, I apply negative 1 time. But on P3, I apply negative 2 times. Okay. And now when I explore the image, so I will explore these 3 images, and when you do it, here it comes. You will see 3 images this time. P1 will be your original image, whereas P2 will be the negative, and P3 will be, now it will take more time because it's doing a lot of computations. So this, the one that comes first below, the most lower image, that's your original. And this second one, this is your negative image. This third one is basically the double negative. But you can see double negative is 100% same as your original image. Okay. So this is it. This is how we do. And go through this video and pause it and then try it yourself before you try to go next. So this is what we do till now. What we did in this lecture is we studied the sunset effect, the lighten and darken using the make lighter and make darker built-in functions of JES, and finally we saw how to create a negative of the image. So next time we will continue with the next topic.